This video is sponsored by Squarespace. There's a neat comet out right now. It's called Comet C/2025 A6 Lemmon. That's Lemmon with 2 M's because the comet was discovered at Mount Lemmon Observatory in Arizona. It's currently 3:30 a.m. on October 5th, and I've already set up some gear in a particular spot in my yard that I'm walking to right now. And I'm hoping this is gonna work out. Currently the sky looks really clear. The moon is setting behind the trees to the west, and I'm excited to see what we can get. Okay, that was October 5th. It did end up working out, and I got some good data that we're gonna take a look at in the processing section. But before that, as an update to my comet hunting, it's now October 19th, and I've been waiting and hoping that I'd be able to catch Comet Lemmon again now that the comet is getting brighter and starting to become visible in the evening here in New Hampshire. Right around when it gets dark, you might have an hour. But I have struggled with it as an evening comet. From my yard here, I just don't have the low horizons needed. The trees are just a little bit too tall, unfortunately. Well, and this all leads me into the tutorial, because if you want to try to photograph Comet Lemmon, the first thing you're going to have to figure out is, can you actually see this comet from your location in October 2025? And an easy rule of thumb is, can you, at nightfall, see all of the Big Dipper? Because right at dark, that's when you're good to go and shoot the comet. And if you can find the Big Dipper and then just go a bit west over into Boötes and look for a little green blob, then you found the comet. As far as capture, I strongly suggest a one-shot color camera under the darkest sky you can find. If you're using like a DSLR, it doesn't have to be modified. It could be a stock camera. But the most important things are color camera, dark sky, and there's no need to use any filters. If you do use a mono camera, then you would rotate through RGB filters using filter offsets to shoot. But I just find that mono is quite a bit more of a pain to process than color for comet photography. So I usually do color. As far as optics, if you have a large aperture, very fast telescope like a RASA or a hyperbolic Newtonian or a hyperstar, those would be ideal for comets. But second place, in my opinion, is just using a fast telephoto prime lens or a fast refractor. So this is what I used, the Rokinon 135 f2 wide open. I think it's a good choice, especially with a cooled one-shot color astronomy camera like this ASI 2600 MC. So can you shoot the comet with a C-Star, a Dwarf 3, a slow telescope, a kit lens? Yes to all. So when I say a RASA or a fast refractor or fast telephoto lens are ideal, it doesn't mean that those are the only options. If you have something else, go for it. You're still going to be able to capture that bright nucleus and the nice green coma around the nucleus. You just might not get the long tail as well, because that's a very dim part of the comet. But no matter what kind of gear you have, if you want to shoot the comet, go for it. And this leads us into exposure settings. You can, of course, guide on the comet's nucleus rather than the stars and go for like super long exposures that way, like 10 minutes. That's going to reveal more of the tail. I've never personally done this. I just use normal sidereal tracking, and if I'm guiding, I guide on the stars, not the comet. And the reason why is I want my final photo to be the comet with pinpoint round stars surrounding it, not streaked stars. And if I guide on the comet and do long exposures, I'd get streaked stars, and then I'd have to go back and image the star field on its own. And to this point, I've just been too lazy to ever do that. Maybe someday I'll try it just to experience it. Of course, the downside to guiding on the stars is the comet is clearly moving at a different rate than the stars. If we register on the stars and make a time lapse over the course of an hour, this is quite clear. But in my experience, the difference in the rates isn't so great that a couple minute long exposure is going to wreck all comet detail. It might just slightly blur that detail, but I think it'll still be pretty decent. Now, if you're very high focal length, then my advice might change. But for comets, I'm usually at lower focal lengths like this Rokinon 135 because then I can capture way more of the tail. And really, that's it. To recap, color camera, no filters, fast optics if you have them. At least like 85mm focal length would be good, 135 would be good too. I would suggest sidereal tracking and auto guiding if you need it, and then just expose as you normally would for deep sky. You don't have to do super long sub-exposures, and try to get, 15, 20 minutes of data with no moon out. You can get longer, but the comet does change pretty fast. And then also get a full set of calibration frames, darks, bias, and flats. So all that said, if you're already a deep sky imager, comet acquisition isn't really that different from deep sky acquisition. Where it gets tricky is the processing. Okay, so we're on the computer now. We're going to get into processing. I'm going to do this in PixInsight and Photoshop, and the reason is because I've already covered Comet processing in Deep Sky Stacker and Serial, and I don't want to just repeat what I showed in these videos. I did watch them because they were made 2 years ago, and I still feel they're fairly accurate and about how I would do it today. So I don't want to remake these ones. So instead, I'm going to show it this time in PixInsight with the Russ Croman plugins, and then finish in Photoshop. And these are all paid programs, but they do all have free trials. So if you haven't already used your free trial and you want to try it now, you could, and follow along with this processing tutorial. Okay, so let's jump right into PixInsight here. I'm going to go to Script, Batch Processing, and Weighted Batch Pre-Processing. And you're going to start with Comet processing just like you would with Deep Sky processing. So calibrating and registering all of your frames. And this, if you haven't used this before, it's just an easy way to load everything up and do it all at once. This is the WBPP Weighted Batch Pre-Processing script. So to use this, there's these tabs up here at the top. We can just load in all our calibration frames. So I'm going to first load in my bias frames by clicking on the bias tab, and then just this little plus bias. There is a way to add all these automatically, but for just a simple set of data like this, I don't usually bother with that. I just go ahead and just add each set. So I make sure that I add the correct frames. So here are my darks. Because for instance, like I don't want to add these JPEGs here that the ASIR created. Just add the fit files. And I'll add my flats. If you want to see what a flat with the Rokinon 135 at f2 looks like, that's it. It says T7 here. That's a mistake. It was from another session, so just ignore that. This was with the ASI 2600 MC. And it's under the name Tania Borealis, because I guess that was a close by star or something. It was in the center of the frame. I don't remember why I have it named that way. Okay, so we've added all of our frames, our calibration frames, and our lights. I have 100 at 45 seconds each. Okay, and then over here in Pipeline, I'm going to turn on everything except for linear defects correction. I usually don't turn that on with my cameras because I have found that it usually creates more problems than it solves. So I'm going to leave that one off, but turn on all these other active steps under Pipeline. And then we just want to set an output directory. I'm going to go ahead and make a new output directory on the desktop just for this tutorial, so I don't get confused with previous work I did. All right, and then we can just click Run and Continue. Okay, that finished successfully, so I can exit out of this script. And if we look on the desktop now, you can see here's my Comet Lemmon folder, and it has all my calibrated, debayered, registered, and master files. Okay, so then we're going to do more pre-processing now. We're going to go back to up here to the menus, go to Process, go down to Image Registration, and choose Comet Alignment. So find the process called Comet Alignment. Okay, and then in here, what we're going to do is we've already registered all of the pictures on the stars, but now we're going to register them all on the comet's nucleus. So we're going to go Add Files. We're going to go to our registered folder in the folder where we did the pre-processing. And you can see these have been calibrated, debayered, and registered. And we're going to select all of these files here and open. Okay, it's opened all the files. You're then going to double click on the first file in the list. Okay, and it's in a linear view mode. So we want to just open up screen transfer function, unlink the channels, and hit the radioactive button. And now we can actually see the picture. And then we can zoom in here on the comet's nucleus, which is right there, and just click on it. And you can see when you click on it, it sort of auto locks on with this little crosshairs. So you don't have to be super precise. If you click anywhere near the nucleus, it's going to auto find it for you. And then I'm just going to go down to the very last frame, the number 100, and double click that. And again, do an unlinked auto stretch. Okay, you can see there's a bit more light pollution there. But again, we're going to zoom in on the nucleus and click on it. And again, it automatically sort of locks on there with the little target. And then it basically will now, just from doing that on the first and last frame, be able to calculate where the nucleus is in all of these frames. Okay, but just to show you that that is true, let me just go ahead and open one here in the middle of the frame list. And you can see it does have this green crosshairs on it. If we auto stretch that, we can see that that is indeed on the nucleus of the comet. So basically it's able to calculate on all of these where the comet's nucleus is just by manually selecting it on the first and last. And then we can just set an output directory. So I'm just going to click on this little folder icon and I'll make a new folder called Comet-Aligned. Okay, and then hit the little circle icon down here to apply this process globally. So whenever you're applying a process to external files that are not open here in PixInsight, you apply the process globally with the circle icon. Okay, and then it goes through and it makes comet-aligned photos. So we'll let it do that. Okay, that's done. So I'm going to go ahead and close these out. The next step is we want to use a Russell Croman plugin called StarXterminator. So you'll need that for this step. And what we're going to do is we're going to remove all of the stars from all of the comet aligned photos. So we'll go to Process, Object Recognition, StarXterminator. We don't need star images, so we can uncheck that. We do want to do a batch process. So we'll click on this little button that says Process Batch. And I want to output the starless files to a new folder called Comet-Starless. Okay, and then I want to click on Select Input Files and Execute. And then I'm going to choose all of my Comet-aligned files to make starless. And open. Okay, it says 100 files will be processed. That's fine. Click OK. And then it will go through this process of removing the stars from every photo. Now, this will depend on the speed of your computer, how fast this can go. If you do the NVIDIA GPU acceleration with a Windows computer, it can go much faster. For me, on a newer Mac, it'll probably take, 20 minutes or something, maybe 10 minutes, I don't know. But anyways, I'm going to speed up or cut out this part of the video, and then we'll see what they look like after this is done. Okay, the batch process of StarXterminator finished. So now if we go File Open and just take a look at one of them, do an auto stretch. Okay, it looks like this. So you can see the comet there. You can see the tail going out this way. Of course, there's a lot of sky gradient. This was in the early morning hours, so not too high in the sky. So this is expected probably a little bit later, actually, after the moon set. It might look a little bit better. Let's try one in the middle of the range. Let's see. Yeah, definitely a little bit better. Sort of some halos left on some of the stars there, but you can see more of the tail a little bit later in the range. You can see the tail extends all the way to the edge of the frame there. Now, I perhaps didn't spend quite enough time on framing this. It probably would have been better to do a diagonal, because then I could have gotten a little bit more of the tail rather than this straight up and down. But I was sort of rushing, and it was very early in the morning, so my brain wasn't quite working fully correctly. But I still got, plenty of tail here to work with. Okay, so we've registered our subs twice. We've removed the stars from all the Comet aligned images. Now we have to stack the Comet aligned images. So we're going to go to Process, Image Integration, Image Integration. We're going to add all of the Comet starless files, and we will do just default parameters, except under pixel rejection 1, we're going to set this to Windsor's Sigma clipping, and then we'll apply this globally by hitting the little circle icon. Okay, and then here is the result after it finished the process, and you can see it doesn't look too different than just a single frame, but maybe the tails come out a little bit better. But if we zoom in, you can see there's a lot less noise now that we've stacked a bunch of frames. The next step is I'm going to go ahead and open up the stars image as well. So we'll do File, Open, Master Light. Okay, we can get rid of these rejection frames. We don't need these, but you can see there was a lot of satellite activity in the early morning hours. But here is just the master integration with registered on the stars. And if we zoom in, we can see the problem of just using this. The tail looks sort of okay, but look at the nucleus of the comet. This is how much the comet moved over the course of taking these sub-exposures. So obviously that isn't good, but if we look at this one, where we comet aligned, that looks a lot better. Now I'm still getting some streaky stuff in the background here. I believe the reason for that is because I didn't auto guide. So this, and I probably didn't do the polar alignment very well. So this is drift, walking noise drift kind of stuff. So I think that while this isn't ideal at all, it is realistic to what probably a lot of people's data might look like. Basically, what we want to do now in processing is just keep all of this tail information from this photo, but use this one for the actual background and stars and everything else, because this one is going to be a lot cleaner, right? So it's just a matter of combining these two things together. This is also pretty cool. That night there was this is called the Little Pinwheel Galaxy right here, and look at how close it was to the comet. There's the comet, and there's the Little Pinwheel Galaxy. So that's pretty neat. Anyways, yeah, the goal now is we need to process both of these images and combine them in a pleasing manner. Okay, so the first thing I'm going to do is let's go ahead and put one on top of the other, and you can see they are pretty well aligned. So I'm going to crop both to get rid of this registration artifact. So I'm going to open up Process, Geometry, Dynamic Crop. We'll sort of set up our dynamic crop on this one. I'm just going to take a little bit off each edge to get rid of any black bars, registration artifacts. And then once we've set up the crop correctly, we can just drag off this little triangle here and close this. And then apply this process by just dragging it onto both. And that's how to crop two images the same in PixInsight. It's a handy little thing. Once we're done, we can delete this icon. Okay, and so just to show you that worked, if we resize both of these back down, you can see they are still pretty well lined up. Now, the nucleus of the comet, of course, stretches from here to here on this one. And on this one, it's basically on the comet aligned one, it's just in the end position of that. But that's okay. It's close enough that that'll work out fine. Okay, next thing I'm going to do is I'm going to run automatic background extractor on this one. You might ask, well, why not dynamic background extractor? I've just found with something this simple in terms of a gradient that the automatic works just as well. But of course, you can use whatever kind of background extraction you prefer. I'm going to turn up the box size and box separation, turn down the function degree to 2, because this is a fairly simple gradient, and set the correction to division, and then just apply that. Okay, there's the result after the background extraction. You can see there's a lot more detail in that comet tail now. And it's sort of bluish colors coming out as well. We'll just go ahead and apply that same correction to the star image. Okay, and after background extraction, it looks like this. Okay, so then I just basically want to stretch both of these images. So I'm going to use something called generalized hyperbolic stretch. If you don't have this one, you can download it. It's from Mike Cranfield's website. I'll put the link in the description. And so how this works, let's go ahead and open it up. Intensity transformations, general hyperbolic stretch. I'm going to click on the image in the background. That sets this yellow line. That's called the symmetry point, but you have to actually then click this button that says send to SP. Then you can see the symmetry point is down here. I'm going to go ahead and turn off the auto stretch. And then we'll just do an initial stretch. And for this initial stretch, you can always set the local intensity to something quite high, like 11 or 12, and then bring the stretch factor out like this so that you can actually see the data you're working with and apply that. Okay, and you can see that looks pretty good, but for this comet data, I really want to stretch actually for the comet. So I'm actually going to click on the comet's tail, and you can see the symmetry point gets set right there. I'll click send to SP, and I'll go ahead and turn on a real-time preview so I can see what I'm doing. Okay, and that looks pretty interesting. It's definitely bringing out a lot of the tail, but probably overstretching on the comet's nucleus. So you could, if you want to sort of optimize for both, do this stretch plus another stretch for the comet's nucleus, or you can try to sort of hit a middle ground with GHS. I'll try to hit a middle ground. So I'm going to bring down the local intensity, bring down the stretch factor a little bit, and I'll protect highlights a little bit. Something like that. Okay, let's see how that looks. I think that looks pretty good. I mean, you know, if you're really trying to not blow out the nucleus, you could do that, but a comet's nucleus is supposed to be bright, so I'm happy with how that looks. Now, there's of course a lot of detritus, weird stuff in the background here. Don't worry too much about that, because when we blend in Photoshop, we can get rid of all that stuff. And I'm going to do the same thing for this image. I'm going to use generalized hyperbolic stretch to stretch this out. So same thing, we're just going to use the symmetry point and bring out an initial stretch. With this one, since there's so much sort of dead space here, I might go into linear mode and just move this back a little bit with the linear black point correction. And then go back to generalized hyperbolic stretch. And we'll look at a real-time preview. Yep, that looks good. Apply that. Okay, and I think that looks pretty good in terms of the stars and the background and everything else. So now it's just a matter of taking these two stretched images, this one more for the comet, and this one more for the stars, and combining these two things in Photoshop. But to do that, we'll have to save them as 16-bit TIFFs. So we'll just do File, Save As, call this one stars.tiff. Save it as 16-bit integer. And then we'll save this one as comet.tiff. Okay, so I've opened the stars.tiff in Photoshop and the comet.tiff in Photoshop. This is what they look like. And then I'm just going to select all on the Comet image and edit, copy it, and edit, paste it as a layer onto this one. Okay, and since we already checked out the alignment and did the crop in PixInsight, they should be pretty well lined up, but we can just double check that by turning off and on the visibility of the Comet layer. And I can see, let me just zoom in and make sure. It's maybe a little bit off. Let's turn down the opacity and see if we can make it any better. Maybe right there. I'm just using the move tool to sort of move it into place. Let's see if that made it any better. Okay, I maybe improved it just a little bit. Okay, so next up, if we just change the blend mode on this Comet only layer to screen, it looks like this, which is already looking pretty cool. And then we could do an adjustment layer, curves, and basically just fix the black point. And this is, an okay rendition, but if we look at the background closely, you can see it is very noisy because of the addition of the Comet image, which, if we remember on its own, looks like this. So the background is very sort of noisy looking. I'm just seeing, since I moved it over a little bit, we're getting a little bit of a gap of data on that side. So let me go ahead and crop that out while I'm thinking of it. Okay. So anyways, this curves definitely improved the image. We could probably improve the image a little bit more by saturating the Comet layer, because the green isn't really showing up too well. But before we do that, one other thing we can do in here is basically just make a mask on the screened Comet layer so that we don't get any of this messy background stuff. For the background, we're just using the background. Okay, so to do that, what I suggest is we're going to Alt-click or Option-click the eyeball on this Comet layer. So we're just seeing that, and select the whole thing and copy it, and then make a layer mask. So click on this little Add a Layer Mask button down here in the lower right of the Layers panel. It's this little icon right there. And so you can see there's now a layer mask there. And then Alt-click or Option-click on the layer mask. So you're seeing it. You can see it's just pure white. And then you're going to paste in the image itself. And so this seems sort of bizarre, right? What are we doing? Pasting the image of itself into its own layer mask. Well, this is creating a luminance mask, right? Okay, so, and with a luminance mask, we can then edit this luminance mask so that it's only picking up the comet. But this is a good start for the mask, is the data itself, of course. So I'm going to go ahead and deselect now. Okay, and I'm going to edit this masked directly. So I'm going to press Command L for levels, and I'm going to bring down the black, or bring up the black point, and bring up this one. So we're just trying to select sort of the comet here. Now, of course, this doesn't look very good because there's still so much crap in the background. We don't need any of this, so we can literally just paint in black on it with a brush. Don't get close to the comet yet, but we can get rid of all of this stuff safely because this is all just detritus that we don't need. Mask now looks like this. The image looks like this, which is a big improvement because now if we zoom in on the background, it looks very clean compared to what we had before, right? But if we look at right around the comet, there's still clearly a division there. So the easy way to fix this is basically just go click back on that mask and feather it pretty dramatically, like many, many pixels. And then that edge won't show up nearly as much of where the mask is. And if we look at the actual mask now, you can see it's very feathered. Okay. And we can now actually probably, now that it's that feathered, increase the brightness of the mask a bit, which will bring in more of the comet's tail. Okay, then I would maybe want to apply a saturation boost to the comet. So I'm going to click on Hue/Saturation as an adjustment layer, and I'm going to clip this adjustment layer just to the comet layer here. Let me just rename this Comet so you know what I'm talking about. Okay, so I'm going to clip this by holding down Option or Alt and clicking on the little line between them. That clips this adjustment layer to this one. You can see that with the little bent arrow right there. And then I can just increase the saturation on the comet. And you can see the green came out, the blue in the tail came out. It looks really cool. Okay, if I wanted to do the same thing for the stars, I could just select the luminance of the background, right? So like we can turn off all these other layers, select this, do a hue/saturation, go into the mask and do a luminance like this. Adjust this so that it's just sort of selecting the stars and the comet, but the comet will be covered up. And turn everything back on, and then I'll apply a little bit more saturation on the stars as well. Okay, and then as a final little touch, we can do one more adjustment layer and do curves, and we'll just put in a final black point adjustment for this beauty. And that's about it. Now we could just pick our final orientation. I sort of like comets and they look like they're like coming down to Earth. So I'm going to turn this 90 degrees clockwise. And this is actually how you would see it in the sky too. So I think that looks really cool. Okay, so hopefully this has been helpful for people who have PixInsight and Photoshop, this processing part of the tutorial, and I hope many of you can go out and shoot Comet Lemmon. But once you do, what should you actually do with it? Well, what I would suggest you do is put your finished Comet photo on your personal website, like mine at nicocarver.com. My site was created completely with today's sponsor, Squarespace. Squarespace is the all-in-one place to get your own website up and running without any coding knowledge. Squarespace makes that super easy due to their professional templates that are drag and drop and their design system called Squarespace Blueprint. I can quickly change the appearance of my site through intuitive controls that update immediately. And I love that everything I need is built in, ready to go. Right away, I could start using a spam-free contact form. And if I ever needed to sell something on my website, Squarespace has you covered with easy-to-use templates for selling services and products, and plenty of options for payment for selling those things, from PayPal to credit card to Afterpay. So if you need a website, check out squarespace.com/nebulaphotos for your free trial. And if you like it, use code nebulaphotos at checkout for 10% off your first purchase of hosting or a domain. And since this video is over 20 minutes long, you're now seeing the names of everyone who supports this channel on patreon.com/nebulaphotos. Patreon members get a bunch of exclusive benefits like one-on-one messaging support with me, tons of additional channels on my Discord server, including the monthly imaging challenge, a Zoom call with the whole Patreon community the first Sunday of every month, and a monthly bonus video. This month's bonus video is also PixInsight related. It's using PixInsight to process an exclusive data set that I'm giving away for Patreon members, which is the Seahorse Nebula that I shot at Starfront Observatories. And so if you're interested, this all starts at just $1 a month. There are additional benefits like early and ad-free videos starting at $7 a month. So I think it'll be well worth checking out if you appreciate what I'm doing here on YouTube. That's it for this one. See you next time for another astrophotography video. As always, this has been Nico Carver. Clear skies.